Hi everyone, welcome back to Mathematics for Engineering 3. Today is going to be the last video of chapter 3, the Laplace transform. Okay, in this video is going to be the seventh section, which is the last section. It's about the integral equations. Okay, so let's begin here. Guys, there's nothing new in this section. You just need to solve these integral equations. It's called an integral equation because first is an equation, right? You have the equation side here, and then you have an integral here. Okay, so you have an integral there, you have the equation. So you want to find ft from that equation. Okay, so whenever you see an equation without the initial conditions or boundary conditions that end with the integral like that, it is called an integral equation. Okay, and to solve this equation, the method is first we apply Laplace transform to the integral equation. Okay, I should change here from differential to integral equation, and then we use Laplace transform. And here the Laplace transform of this guy, we need to use the convolution. Okay, if you remember the Laplace transform of the integral, that can be done using the convolution. Okay, and then we solve for ft, the Laplace transform ft, which is fs, and then we take the inverse Laplace transform, so we get little ft. That's it. Okay, so let's try to solve this integral equation. First, I'll begin by take the Laplace transform of ft, and that is, what is it? Laplace transform of psi t minus Laplace transform of integrate 0 to t fx e to the minus 2 t minus x dx. Okay, and if you know, this guy is quite simple. Laplace transform of psi t, that is, what is it? 1 over s squared plus 1, right? That is from the formula. Okay, and for this Laplace transform, we need to use the convolution, right? The convolution. So here it would be fx, and in that case this guy will need to be g of t minus x. Don't forget, guys, the convolution, if you have the formula with you, is the integral 0 to t fx gt minus x dx. That is convolution of f and g. Okay, okay. So if we know that gt minus x is e to the minus 2t minus x, it means that gt is actually e to the minus 2t. Okay, so we know that Laplace transform of integrate 0 to t fx e to the minus t minus x dx is actually Laplace transform of ft, and then e to the minus 2t, and that is Laplace transform of ft times Laplace transform of e to the minus 2t. Okay, guys, if you remember, here this guy is gt minus x, right? So we have gt here is e to the minus 2t. So we have the gt here. Sorry, here is not the function of x, it's function of t. Okay, so we have fs times Laplace transform of e to the minus 2t, that is 1 over s minus minus 2, which is s plus 2. Okay, so from here we have that the Laplace transform of ft is the big S, the big Fs equals 1 over s squared plus 1, right? I plug in this in there. Okay, and this guy is actually this guy, right? Which is this. So I have here minus Fs over s plus 2. Okay, and then I have Fs plus 1 over s plus 2. Fs plus Fs equals 1 over s squared plus 1. And I pull Fs out. So I have here 1 plus 1 over s plus 2. 1 over s squared plus 2. And then it would be Fs s plus 2 plus 1 divided by s plus 2. And that is 1 over s squared plus 1. So here we have Fs times s plus 3 divided by s plus 2, and then 1 over s squared plus 1. So we have that Fs is, let me remove my video. So Fs is s plus 2 divided by s plus 3 times s squared plus 1 times s squared plus 1. Okay, and then we do need to do partial fraction for this guy. Okay, we do need to do partial fraction for this guy. Okay, and I will show you here. So we have that s plus 2 divided by s squared plus 1 s plus 3 is a divided by s plus 3 plus bs plus c divided by s squared plus 1. Okay, so basically we want to do the partial fraction for this term. Okay, and how to do that, guys? Here it would be a s squared plus 1 plus bs plus c s plus 3 divided by s plus 3 s squared plus 1. So we have s plus 2 equals a s squared plus 1 plus bs plus c s plus 3. Okay, and to solve this, first I'll just let s be minus 3. So the left hand side would be minus 1, and here it would be a 9 plus 1 plus 0, which means that a is actually minus 1 over 10. Okay, we know right now that a is minus 1 over 10. Okay, so next I'll continue from here. Okay, sorry, I continue from here. So I get s plus 2 equals a s squared plus 1 plus here that will be b s squared plus 3bs plus cs plus 3c. Okay, I'm gonna use the undetermined the method of undetermined coefficients. So what we have here would be a plus b s squared. Okay, a plus b s squared, and then it would be for the s term we would have plus 3b plus c s, and then the constant term would be a plus 3 c. Okay, a plus 3c. And if you look here, this guy, you actually have plus 0s squared. Okay, so if you look at the coefficient here, it means that a plus b is 0. A plus b is 0, which means that b is minus a, which is 1/10. And if b is minus a, which is 1/10, we can get c from this condition. Here we have that the coefficient in front of s is 1, and the coefficient of s here is 3b plus c. So we have here 1 equals 3b plus c. But we know that b is 1/10, right? So we have 1 equals 3/10 plus c, which means that c is actually 7/10. Okay, so we have that s plus 2 divided by s squared plus 1, s plus 3 is actually minus 1 over 10, 1 over s plus 3 plus b, what is b? B is 1/10 divided by s squared plus 1, and then plus c, which is 7/10, 1 over s squared plus 1. Okay, and that is actually fs. So if you want ft, is going to be L inverse of fs. So it's going to be the L inverse of the first one. L inverse of the first one would be minus 1/10 e to the minus 3t, right? 1/10 e to the minus 3t. Is that good? 1/10 e to the minus 3t. And after that, we get plus 1/10 and s divided by s squared plus 1 squared. That is, what is it? S divided by s squared plus 1 squared. That is cos t. And the last one would be 7 divided by 10 of sine t. And that's it. And here, as you can see, it's quite simple. You first apply the Laplace transform through the to the equation, and then you evaluate this Laplace transform using convolution, right? And then you solve for fs. When you get fs, you apply the inverse Laplace transform. Okay, let's look at another example. This one, see, this one is the integral equation. Because why? Because you have an integral here. However, as you can see, you still have the initial condition here as well. Okay, so this guy is a bit like an integral equation with an initial condition. So how to do it? You don't need to think much. Just apply the Laplace transform. Okay, this guy is the derivative as well. So it is actually the differential equation. Okay, it's an initial valued problem, but it consists of the integral. Okay, so it's a combination of the fifth and the seventh sections. Okay, it's an initial valued problem with integral. Okay, so it's quite simple, guys. You just apply the Laplace transform throughout the equation. Equals Laplace transform t minus Laplace transform integrate 0 to t fx cos t minus x dx. Okay, Laplace transform of f prime t. That is simple, isn't it? Laplace transform of f prime t. What is it, guys? I hope you already remember how to find the Laplace transform of f prime t. If you don't, you have the formula in the exam, so don't worry about that. It will be s, right? S fs minus f0. Okay, but f0 is what? Is 4. So it will be s fs minus 4. This is exactly the same as the initial valued problem that we did before in the section 5. Okay, and Laplace transform of t, that is 1 over s squared. Okay, and lastly, Laplace transform of integrate 0 to t fx cos t minus x dx. So guys, we can look at this guy as gt minus x, right? Gt minus x. It means that gt is actually cos t. So this guy is the same as Laplace transform of ft and convolution of ft and cos t. And that is Laplace transform of ft, which is fs, times Laplace transform of cos t, which is s divided by s squared plus 1. Okay, okay, and then we plug in all the thing back into this equation. Okay, so what we have right now would be s fs minus 4 equals what is it, 1 over s squared minus fs times s squared plus 1. Okay, okay, and then we would have that s fs plus s divided by s squared plus 1 fs equals 1 over s squared plus 4. Okay, I push this to this side and I push this to this side. Okay, so what I have here would be s plus s divided by s squared plus 1 equals 1 over s squared plus 4, and that is s, I multiply this thing by s squared plus 1 divided by s squared plus 1 plus s divided by s squared plus 1 fs, and then equals 1 over s squared plus 4. And this guy would be s cubed plus 2s divided by s squared plus 1 fs equals 1 over s squared plus 4. Oops, sorry. Okay, next I'll copy this to the next page. So here it would be that fs is 1 over s squared plus 1 divided by s squared plus 2 and plus 4 s squared plus 1 divided by s squared plus 2. Okay, okay, and to do the inverse Laplace transform of this, right? Because ft, the little ft, which is our solution, would be the inverse Laplace transform of s squared plus 1 divided by s cubed s squared plus 2 plus 4 sorry, plus inverse Laplace 4 inverse Laplace transform s squared plus 1 divided by ss squared plus 2. Okay, and to do this inverse Laplace transform, okay, I'll show you only the first one. Okay, this one you can look at it as, what is it, a divided by s plus b divided by s squared plus c divided by s cubed plus ds plus e divided by s squared plus 2. Okay, and then you need to solve for a, b, c, d, e, so that you can write, write this in terms of partial fractions, write this in terms of partial fractions. Okay, but I'll just give you the results. Here is 1 over 2s cubed plus 1 over 4s minus s divided by 4s squared 1 divided by 4s squared plus 2. Okay, this is from the book. Okay, I didn't do anything, just from the book. And then you just need to apply the inverse Laplace transform to this line. And here, similarly, you need to do the partial fraction. Okay, partial fraction. It's gonna be quite long, and I'm not going to do it. Okay, guys, in the exam, I hope it won't be this hard. Okay, because here it's not very hard. It's just a labor work, right? You need to do lots of partial fractions to get a, b, c, d, and e. Okay, but in the exam it won't be this tough. Okay, it will be a lot easier to apply the inverse Laplace transform. Okay, so I'm gonna leave you like this, okay, so you can just try and do it yourself. And if you did it, if you do it and you wonder if it's correct, one way to check is to sum them and then see if this sum equals to this. Okay, if it is, it is. Okay, and guys, that's it. The seventh section, it's nothing new, guys. The seventh section can be combined with the fifth and the sixth. Okay, it's just that you have an integral in the differential equations or in the equation, and in that case you just apply the Laplace transform, and whenever you see the integral you use the the Laplace transform of convolution functions. Okay, and that's it. So I would say the seventh section is just the special case of the fifth and the sixth. Okay, guys, apply Laplace transform. Okay, and then whenever you see the integral you use the convolution function, right, to get the Laplace transform of the convolution. Okay, and guys, and that's it for for all, for the for before the final one. Okay, so read a lot, do lots of exercises, okay, and be prepared. Okay, especially if you didn't perform well in the midterm. Okay, so try to do better. Okay, so see you after final one. Bye bye. Fighting. Okay, see you.